All right, so Lewis structures. So what does a Lewis structure of a molecule tell me? So it's going to show the pattern of valence, electron distribution in the molecules. So you're only going to visually see and notate the valence electrons. This is really important. We're only going to see the valence electrons because those are the ones on the outside ring or shell of my atom, and those are the ones that are going to be doing the reactions or losing electrons, gaining electrons, or any of that. So those are the only ones I really need to draw and know where they're at and what they're doing. Lewis structures are really beneficial. They're going to be helpful for understanding the bonding in many compounds. Why do some things bond in a single bond? Why do some things bond in a double bond? We'll be able to do that. Lewis structures allow us to predict the shapes. At the end of this chapter, we're going to start to learn what the three-dimensional shapes are. So we're going to say we'll be able to draw the 2D pictures, and then we're going to be able to look at the 2D picture and predict what the 3D picture should look like. But we can only do that if we have the 2D. And then after that, we'll be able to predict the properties. So being able to draw the 2D picture helps us to be able to predict why certain molecules act the way they do. Why do they react with some things and not other things? Okay? So being able to draw the Lewis structure is really important because it's going to help us with a lot of things moving from this point on. So you want to make sure you follow this. All right, so we said to be able to draw the Lewis structure, we have to follow the octet rule. So let's break that down a lot more. And I know there's a lot on this slide. So when atoms bond, when they're going to bond, they want to gain, lose, or share to result in 8 valence electrons. 8 is our magic number. And remember I said that the reason we want 8 is because it's going to try to get that noble gas configuration. 2 electrons in the S, 2 in the 6 in the P, because that's going to be my outside valence electrons, full outside shells, and that gives me my noble gas configuration. But there are some exceptions, and these are the ones you need to know, okay? So you need to know these exceptions. First, helium is happy with 2 valence electrons, not 8. He's happy with less. Lithium really doesn't want to share electrons. He just wants to lose, and that's pretty much all he wants to do. This is the big one. This is the big one you're going to see a lot. Hydrogen is happy when he shares or gains 1 electron, meaning he's happy with 2 instead of 8. Okay? So he wants to put in 1 electron, somebody's going to put in 1 electron, and he only wants 2. So hydrogen is happy with 2 and not 8. Beryllium doesn't really want to share that much. He likes to just lose and become an ion, but if he does share, he's happy with 4. So beryllium is happy with 4. Boron, if he would rather just become an ion, but if he does share, he's happy with 6. So those are kind of your 3 big ones. Helium's 2, beryllium's 4, boron is 6. At the end of this little section, when we start just doing the basic Lewis structures, we're going to talk about how some elements can actually have more than 8. So they can have what's called expanded octets. Okay? And we'll go through and we'll go, and there's going to be steps, and one of the steps would be to look to see if it's going to expand or not. So some elements can have expanded octets. They have to be in row 3 or below, so period 3 or below, and that's because they have d orbitals, and they can put those extra electrons in those d orbitals. But we'll get there. What you really want to know is 8 is the magic number. That's what we're really trying to get to is 8. But if I have a few that are happy with less, and there are some that are happy with more, okay? All right, so on the next lecture, we're going to draw our first Lewis structure.